If you're at the point in your hack pack journey that you've done some software hacks and now are ready for some hardware hacks, but don't quite know how to begin or where to start, this is a video for you. We will be going over some basic hardware setup to know how to do the electronics, make sure it's connected correctly, and then how to use that in the code to make sure the code follows the next steps to make it work through your Domino, IR, turret, whatever robot you are using to be able to implement this next hack. At the end of this video, we will actually go over the full setup for the red light, green light, or the Squid Games setup on the IR turret. There are three main components of when you're adding a hardware hack. The first one is just the physical setup, all the electronics, the wires, the jumper wires, making sure everything is connected correctly. The second part is the setup in the code, making sure that your code knows how to interact with whatever input or output you are trying to add to your robot. The third part is the logic in the code to determine what to do and when to do it. This is how you control the inputs and outputs, determine what is the right conditions for implementing whatever you're trying to do. For example, we'll be going over adding some LEDs as headlights to the Domino Robot. And to follow the idea of auto headlights, as soon as it gets dim enough or there's not enough light, the headlights will automatically turn on. For the electronic side of it, there are varying levels of difficulty. For example, if you have these sensors that come with Arduino, they're fairly straightforward. You have typically the 3, maybe 4 inputs, and they'll tell you exactly how to set them up. You can find multiple Arduino tutorials how to do most of these type of sensors online. Do a simple Google search. It will show you how to connect the wires to the ground, to the voltage, and to the inputs for the Arduino, and then how to just align that in code. When you step outside of the world of the modules, it gets a little bit more difficult because then you need to understand the basics of electronics, how voltage, current, and resistance work to make sure you create a proper circuit for your electronic hardware to work. One of the things I tend to do is always test my electronic setup without really plugging it all the way into the breadboard. And it makes it a little easier so you're not so congested on the breadboards provided by the CrunchLabs team. You can use a bigger one, spread out a little bit more, and test out your circuits without having to implement it directly on the board and have the full code set up. As we add these headlights to the Domino Robot, you can see that I'm still using the Light Dependent Resistor from the light chasing hack that I did a while back. Let's go ahead and see how we added the headlights to the Domino Robot. For both LEDs, you have the signal wire, which comes through as yellow, then you have the blue and green wires to connect to the Arduino, and then the gray wires go to the ground. So I've converted the LDR to be a threshold in the code, where if it's below a certain amount of light, turn the headlights on. And that's how you can modify these type of inputs for a variable type input or a on or off type switch in the code side of things. One key tip is when you see a tutorial explaining how one of these components work with the Arduino, actually use the code that they have if they provide it, put it into your IDE, upload it to your Arduino so that way you can interact with it and understand how it works. And then play around with it. Change some of the settings if they have some, so that way you can test things out. This gets you comfortable to understand the core components so that way when you integrate it into your robot, you know how the individual pieces work the way you need them to, and then you just have to apply them into the code where it needs to go. This is a trimmed down version of the code setup just to get an LED working. As you can see, there are just the 3 parts that make this work. The first part is defining what output pin is being used to determine where the LED is. That's where your wires need to be plugged in to communicate with the LED. This pin mode section tells the Arduino that this pin is using in this way. And as you can see, it's used as an output to let the LED know information from the Arduino. And then you just have the code logic in the loop to know what's going on in the rest of the program. And currently we just say, turn it on. Nothing more than that. Very simple, very basic. Once you understand this concept though, this needs to be integrated into your regular code for these aspects, particularly these top two. You get them set up and then they're done. The code logic will be determined how you want it to implement. Some sensors will need an additional library. Now, what do I mean by library? If you see this include, that typically means there's a library that it is using to simplify the code. It simplifies it by basically doing code behind the scenes for you, so that way you can use functions and stuff that are already created to make it easier on you. To add a library, first of all, you can't add libraries to the CrunchLabs IDE, at least not currently. So you have to migrate to the Arduino IDE or VS Code. And you can learn how to do that in the Discord forum. If you look underneath IDE programming, there is a post for that to walk you through all of that. Or you can watch the video in the card above that is a walkthrough to set up all three IDEs and a review of which IDE is best for you. Of course, right here is where your libraries are. Once you see that you have the library manager at the top, you could type in the library that you are looking for. There shouldn't be any spaces. It's a coding thing. You can't have spaces. So if you type this in directly into that search bar, you should be able to find it. And as you can see, I have it installed already. If you don't, click the install button and this library will be imported into your Arduino IDE for you to be able to use. As you can see in this code, it's quite a bit more than the LED. You'll spend most of your time adding the logic in the code to control whatever the input is or the output that you desire. While there are a lot of tutorials on how to use the individual components, so you can learn how the Arduino interacts with the LEDs and have a little bit of code in a tutorial, where it may be tricky for most is how do you input or implement that into your IR turret or the Domino Robot code to be able to do what you want it to do. And that's where that next level of understanding coding comes into play. You need to understand the logic of what you're trying to do to then write the code for that specific instance. And then the little pieces of code that you learn, such as the digital write, your LED variable name, and then your high or low to turn it on or off, those pieces are very easy to implement in the code wherever. You just need to know when to implement those so it works the way it's supposed to. This is the Domino Robot code now with the setup for these LEDs and the LDR needed for this little hack. As you can see right at the top, these are the four definitions of which pins we are using for all four components. Very straightforward. You just have to know that some pins can only be used for certain type of inputs and outputs. So you may have to look at that just to make sure that it's set up correctly for analog type input or digital type input. Down in the setup, you can see I have those pin modes set up for the three LEDs. In the setup, the LDR does not need anything more. It's just looking for data later on in the loop. So some of them won't have anything in the setup, others will. And then the magic happens while you are in the loop. This is the code running continuously, waiting for input, output, and executing whatever code is in here. As you can see right off the beginning, I am looking for a read information from the LDR. The LDR is providing input data for me to be able to analyze in the code, evaluate it, and to determine how to react. So we assign that to a variable. This variable then goes through this evaluation if-else statement. This statement is just the evaluation looking for that threshold level. If the voltage is less than 700, then run this code. If it's not, run this code. And as you can see, all it's doing is turning them on and then off. Simple as that. If it meets the threshold, on. If it doesn't, off. Simple basic code that is continuously running through this for the Domino Robot headlight code. To understand this principle a little bit better, go ahead and look at my code tutorial for the Squid Games so that way you can see how I implemented the red light, green light blinking to a starting sequence, as well as for the game to dictate how long the red light should be on and then the green light and passing back and forth. Now that we know how these lights work, it's easy to take that information and then apply it to another robot. For example, I threw these lights, these LEDs, on the IR turret pretty quickly out of this simple little code so that when the fire button is pressed, the white lights turn off and the red light that you don't always see turns on. For the grand finale, here is the way to connect the red light, green light, and the distance sensor so that way you can have the setup for the Squid Games red light, green light game. So to simplify this, we're going to kind of break it down to just the wiring needed that is added. So I've got the IR connection as well as the motors, servo motors, which we don't need for now, and the power cables will just disconnect and move out of the way. So just to understand the added parts for the red light, green light, you have the distance sensor and your two LEDs. Just like the LEDs that we've been playing around with, you have your signal wires going into whatever pin designated, and in the code, the red light goes into 2 and the green light goes into 3, while the other side, your ground side, goes into the black or the ground. So those are simple enough like any other LEDs. And then you just have to have the code to dictate whether they turn on or off. The distance sensor by itself is 4 wires. You can see I have the color coded for the red and the black that match the red and the black. So those are very simple. It just shows that it's the ground or GND and VCC side of where you need to plug that in. Then you have the echo pin and the trig pin. And those, again, just simply go into the board as a digital number of which one you're going into. And the code gives us that the trig pin is 7 while the echo pin is 6. So all you have to do is run your wire from the trig pin, which is the blue, down to 6, and the echo pin, which is green, into 7. Now you are all set up, and you can watch this video to see the entire code walkthrough.